Today is the last of the palindromic dates. I'm kind of sad to see them go. We'll have to wait another 13 months before we see them again. So today is 32923. Again, we won't see any more backwards dates for a while. 32923, 32923. Neat. So today we are going to be solving quadratics. Solve quadratic equations, I should be more specific. And we will be doing them today by graphing. I hadn't really planned this. I received some inspiration in my mind as I drove home yesterday, and I thought, we really should do this because I never know when this is going to pop up. So I thought it would be good for us to see what this looks like. By the way, you won't be having to do, is that good grammar? You won't be having to do any graphing by hand. We will maybe, if time permits, start graphing some quadratics manually by using fancy witchcraft stuff. Today, we're going to rely on technology. So you won't need your Chromebooks yet. You will, once we start working, you'll rely on them completely. So there's a website that's going to serve as a beautiful graphing calculator. I'm sure you've used it before. It's called DESMOS. If you haven't, well, boy, it's great. And DESMOS will do all the heavy lifting for us. It'll graph all of our quadratic functions. And then we will use that sort of as an assist to help us solve quadratic equations. So I know that we're solving by graphing because that's what I said, but I wanted to start the lesson by actually solving a quadratic just by hand, just the way we've been doing, so that you can see the connection between what we know how to do and what we're going to learn how to do. So just as I mean, this should be a complete warm-up. If I put x squared minus x minus 30 equals 0. So this should be, by now, like almost an insult to your intelligence, right? So step one, remember, we set it equal to 0. It's already done. Step two is we factor. So when I factor this left-hand side, I'm going to put x's in the fronts of my shells. What are my signs going to be? Yeah, I mean, if there's a negative right there where I'm pointing with that yellow arrow, then that's all I need to know. If there's a negative there, then 100% we're sure that no matter what else happens, our signs will be one of each. We might want to switch the plus and the minus to a minus and a plus. That's fine later down the line. That's okay. And then we just remember, go through the hunt of numbers that make 30, which two I hope obviously come to mind. Yeah, this is all about the 6 and the 5. There is 3 and 10 and 2 and 15 and 1 and 30. We're not interested in those though, because there's a hint in the problem. There's this 1 that's right in front of the x, this minus 1. And that tells us that we're looking for numbers that are 1 away from each other. So we definitely want to put the plus with the 5 and the minus with the 6, because we want the balance when we do our blue-green to come out. Correct. We want it to weigh out in the favor of the minus and not the plus. So what would my answers to this quadratic equation be? X equals, very good. So that's not what we're doing today. That might prove to be part of the process, depending on, and you can give me some feedback in the later examples as to if it makes sense, like is the flow correct? But really, we're not factoring today unless we have to. What we're going to do today is we're going to rely on DESMOS. So again, you don't need your Chromebooks yet. You can just kind of follow along with what I'm about to do. But when we eventually get our Chromebooks out, we're going to go to a website. It's just DESMOS, DESMOS.com. Like you'll bookmark this. So trust me, you're going to be using this a lot. And this is the utility that they use on YTOP. So when you have a little application like a calculator or a graphing thing pop up, YTOP uses DESMOS. So getting familiar with this interface is a good thing. So what I'm going to do is I'm going to head over here to the left. Up in this left corner, there's a box. Let me zoom in a little bit so you can see a little bit better. So you're going to go into this box, and your box is going to look empty like this when you first get there. And what I'm going to do, since you have your notes in front of you, is I'm going to type in the function, the equation part that is equal to 0. So like in our case, the problem that we just did is we just did x squared. So I remember I go F or X and then I hit Shift 6. You guys know that on your keyboard. And then I arrow out, because if I keep typing, you see what happens, how I stay up in the exponent. And remember, we don't want that. So when you want to leave your exponent, just hit the forward arrow to drop back down. And then I'm going to type in minus x and minus 30. And I'm going to let Desmos do the work. Now, at this point, you look at the graphing and you think, well, like, well, there's nothing there. So a couple tricks. Number one, you see this home button right here? Kind of moving my mouse over here. It's the default view. If I click on that, it takes me back to a standard 10 to 10 something to something graphing window. That's kind of universally accepted as what a graphing window should look like. And you can, with your keyboard or your mouse or whatever, like I can scroll out, I can zoom in, I can do all those things. What I want to do is I want to get a window where I can see where the graph crosses the x-axis. So like I can go down here and I can find the vertex, I can find all sorts of things. I can customize this however I want. We'll play more with it whenever you want to. But for now, what I'm interested in are the points where the graph slices through the x-axis. And you can see them. I mean, it's impossible not to see what I'm talking about. So here's one of the points right here. And if you put your mouse on it and click, you can see, if you just hold it down, that the name of the point is 60, right? And so that should be a connection for you. If you go back and look at our notes page, remember one of our answers was right there, x equals 6. That's pretty remarkable, right? And then if I go back and I look and I just, again, you can zoom out, you can grab and pull. It's really super user-friendly interface. And then if I go and look at the other one, it's obviously going to be what we thought it was going to be, and that is -5. So we're going to be using Desmos today to guide us, and there will be problems where you don't even have to do any math at all. A little bit. Maybe you got to get all the stuff onto one side, but that doesn't really count. Like that's easy. So like if this problem showed up on a worksheet, when it shows up on a worksheet, you won't really do anything on paper. Quite frankly, you'll just write the answers because Desmos is going to give us the answers without actually doing anything at all. Does that kind of make sense what I'm going for there? That you can literally just see the answers. Like you can see the places where the graph just chunks through the x-axis. It's a no-brainer. Now, they're not all that easy. So for an example of that, the next one I want you to write into your notes is a squared. And I'm going to use different variables, but understand that when you type them into Desmos, you can just always type them in as x's. And you quite frankly should, because x is the universally sort of accepted independent input variable. So just always switch a's and b's and m's and v's. Just when you go to Desmos, x's, just put them as x's. But I'm going to use different ones in my notes because I want you to be comfortable or familiar with the fact that this is going to happen. So let's say you're doing your worksheet today and you get to problem 3 and this is problem 3. What's the first thing you're going to do? Yeah, you're going to get that -6 up out of there because none of what I'm talking about today makes any sense or has any relevance if we don't have something equal to 0. So if I move the -6 or the -6 over here, my actual function is a squared minus 7a plus 6 equals 0. Right? So again, there's nothing to it. I'm going to head over to Desmos, and you can just hit the X up here in the corner, and it'll just kill that function out. You can have a bunch of functions, and Desmos will color them differently. It's really neat. But I'm just going to kill it and put in a freshie. So remember, I'm going to switch my a to x, and I'm going to do x squared minus 7x, and then what was at the back? Plus 6, and you don't put equal 0 or anything. You just put in the meat and potatoes part of the equation. And again, feel free, just hit the home button, reset it. And if that doesn't do enough, just scroll out, scroll in, just monkey with it all you want. And so what are the answers? If we had done this problem ourselves, what would we have gotten? 1 and 6. Right? So that reveals to you that the factors, had we factored this, which would have been easy, by the way, it would have factored into parentheses x minus 1, parentheses x minus 6, because the answers that pop out obviously are, you can see them, there's 1 and there's 6. So on your worksheet today, all you have to do is write in the x equals 1, x equals 6. You don't have to do any math. Okay, now they're going to get a little stranger at this point. So the next one I would like you to put into your notes is 3a squared equals -4 plus 13a. So yeah, like I said before, there's a little bit of work on the front end. Like we got to do a little bit of this stuff, right? So if I get this properly set up, what do I have to do? So, right. So I'm going to leave the 3a squared the heck alone because he's positive. Don't mess with him. Everyone goes to the positive x squared side, right? So the 13a is coming across as a minus 13a. The -4 is coming across as a +4. Set it equal to 0. Bless you. And it's at this point that we basically step out and then head over to desmos.com and we type it in. So again, when I go to Desmos, I'm going to type it in using x's. So I'm going to kill that and I'm going to type in 3x squared minus 13x plus 4. You can see this. Actually, we see one of the answers on our screen. It's kind of neat that that happened. But as always, just hit the home button, reset. And there's the reason I'm doing more than 2 examples with you is because I want you to see if you've already like mentally checked out, like this is easy, don't do that. You are going to encounter a dilemma now where we're not sure what this one is. Like you can zoom in on that all you want, and you're just not going to be able to figure out what it is. I can click on it. Can you tell me what that is? It is. It's a 0.3 repeating. And some of you are familiar with what that means, and some of you are not. Do you know what 0.3 repeating is as a fraction? We don't want decimals. So this, I know what it is, and I'm not going to tell you. You will figure this out. You'll practice, you'll get it. But what I wanted to say to you is I may not know what this one is because Desmos isn't going to turn it into a fraction for me, for the record, at least not that I'm aware of. So what I'm going to do is I'm going to go to the other guy and hope that he provides me with more useful information. Okay, so I'm going to scroll across and I'm going to go find my other 0, which is right here. And I like this one because what's his name? His name is 4. Got it? So what I'm going to do now is I'm going to be smart about this. I'm going to head back to my other workspace now, and I'm going to say that I know from Desmos, thank you, Desmos, that one of my answers is 4. If anything is going to lose you in today's lesson, it's what's about to happen. I don't want to move on until you guys all agree that if one of the answers is 4, then one of the factors had to be a -4. Would we agree with that? Because just like we've been doing for several days now, I would ask you what makes this equal 0, and you'd say, oh, a equals +4, right? So the reason I'm telling you this is because it's going to help us now with a little bit of reverse engineering. It's going to help us to figure out what the other factor would have been. We've never done like reverse engineering factoring before, but you're all bright enough. You can handle this. What can you tell me? Think hard now. This is the thinking part of today's lesson. This is the part Desmos can't do for you. Follow my white arrow. What literally has to go right there? Right, because whatever I put there has to multiply by a to make 3a squared, right? Now, looking at the problem originally, you and I both knew that because the number in the back is a positive, that both signs have to be the same. So if the one, the a -4, has a negative in it, then this one has to have a negative in it. And then finally, just some basic like second grade reverse engineering. Follow my little green connector here. What has to go where this green arrow is pointing so that it multiplies by 4 to make 4? 1. And having said that, now you can look at this and say, oh, of course, I knew that. What Desmos was telling me, look at the answer that comes. I assume by now you've done enough worksheets, you know that that means that a equals 1 divided by 3, right? And then you go back and you look at it, and in hindsight, you're like, oh, Desmos was telling me 0.3333. And again, some of you come to me with this knowledge and some of you don't. But a very common decimal to fraction conversion is the fact that 0.3 repeating is the same as 1/3. And again, in hindsight, you might look back and go, duh, I knew that, right? What would we say if Desmos gave us like 0.5? This one we know. What's that? We would get 1/2. What will we say if Desmos gives us like 0.25? 1/4. What would we say if Desmos gave us 0.1? 1/10. What would we say if Desmos gave us 0.75? 3/4. Very good. So familiarize yourself with those basic decimal to fraction conversions, and you'll save time over your neighbor today who doesn't want to memorize those. You need to know basic decimal to fraction conversions. 0.3 repeating is a third, 0.5 is a half, 0.25 is a fourth. Here's a tricky one. Let's see if anyone knows this one. What if Desmos were to give us 0.125? Does anyone know that one? No. Would you be willing to make this observation that these two, the bottom one is exactly half of the top one? Would you agree that 12.5 cents is exactly half of 25 cents? So it would be an eighth. Because if 0.25 is a fourth, then 0.125 is exactly a half of a fourth, and a half of a fourth is an eighth. Okay. So far, so good. So again, I'm not doing the lion's share of the work today. Once I get good at this, I'm letting Desmos do all the heavy lifting. And I'd say more than half the time on today's worksheet, I won't even need to do this. This is something that we'll do today when we have to. When we don't quite know what that weird decimal one is, then we'll use that reverse engineering process to figure out what he was. Okay, next one, I got 2 more and then it'll be work time for you. So the next one I have is 4x squared plus 4x plus 2 equals negative 16x plus 5 minus 3x squared. So we've certainly got a little bit of work on the front end to do, right? There's a lot of prep work before we can cook this meal. So are we pulling to the left or pulling to the right? Definitely coming everyone to the left. And it's not about where is there less work to do. It's about we are a slave to the x squared term. And we say, I will go wherever I can make you positive, right? So I'm pulling the minus 3x squared across to the left by adding him, creating how many x squareds? Nice job. And then I also have to pull my minus 16x across by adding him. How many will I have? Plus 20x. And then finally, I will be pulling my plus 5 across by doing minus 5. And what will I have? Minus 3. And I have now all the prep work done. It's time to do the thing. So you guessed it. At this point, I'm going to head over to Desmos. So I got 720 negative 3. So I'm going to do 7x squared plus 20x minus 3. And right now you can see I'm zoomed into a place that's not interesting, right? The graph misses this window. So again, hit the home button. And generally you're going to find today that the home button will show you everything you need. I don't think I have any that are outside that 10 to 10 window. So I'm going to zoom in. And again, I'm going to find the ugly one first. So, I mean, I challenge you to tell me what, like, that's hard. I almost missed it. There it is. So when I click on that, I get what is this? 0.14290? Again, that's the one I'm going to stay away from. I'm going to reverse engineer him here in about 30 seconds. But the one I like, the freebie, and I did set these up so one should be easy to find and the other might be harder. So who's my freebie? Negative 3. Do we all agree with that? So if negative 3 is an obvious answer, this is the part where I saw some funny looks last time. If negative 3 is an answer, then what is one of my factors? X. X doesn't equal 3. Stop that. X equals negative 3. What is my factor? X plus 3. You have to think backwards about what would be in the parentheses if I were doing this yesterday? What would have had to be in the parentheses for me to say x is -3? It would obviously have to be x plus 3 because that's how a -3 spits out. And again, I can reverse engineer now. We're about to uncover the identity of that crazy decimal that we're like, who are you? Like weirdo. So I'm going to reverse engineer now. I'm going to build a blank shell and I'm going to use some common sense. First off, what has to go where this white arrow is pointing? It has to be 7x because I'm reverse engineering a 7x squared into my answer. It's got to be there. You'll never not know, by the way. If you get one free answer, you'll always be able to reverse engineer this every time. Every time. And then again, you got to know your stuff. You got to, this can't be like kind of, and you got to understand the signs. If the back has a minus on it, what does that mean about the signs in my factors? Positive and a negative. And I've already used the negative, or I've already used the positive. So I need a negative. And finally, duh, what do you have to put right here so that it times 3 equals 3? 1. And that reveals why we had no idea who that decimal was. Because what is the answer? 1/7. And that's why we don't know what he is. Like, who in their right mind knows that the decimal version of 1/7 is 0.1429? I don't even know that. I do this all day, every day, and I didn't know that. But I didn't have to know it. I was able to reverse engineer it out by using the one that I knew to gift me the one that I didn't. Okay, one more example. And then you'll get some time to work and ask some questions and all that good stuff. So the last one for your notes will be, and why don't you guys actually do me a solid? Will you guys all flip? Let's do this right now. Why don't you all open up your Chromebooks? I'll give you like 30 seconds. Flip those bad boys open, and let's all get to Desmos. Let me write it up here for you. DESMOS.com. I don't know who created Desmos. I've researched it before. Whoever they were, they're not out to make a buck. There's no advertising. There's no, by the way, there's an app you can get on your phones for Desmos. And it's beautiful. And as always, there's no apps. There's no premium version. It is what it is. So whoever made it had one mission, and that is we collectively as a team of computer programmers and mathematicians want to make the future generations understand math better. That was their only objective, completely. And I love them for that. This is a beautiful, beautiful website, a beautiful application. When you go to desmos.com, the first thing that your screen should say is this. Y'all see that? So I hope it's obvious what to click on the big blue button that says graphing calculator, and it'll bring up just the exact same interface that I had. So now that you've all got Desmos open, just get your notebook kind of slid up there, and let's go do all the work we have to do on paper first. And the paperwork is the prep stuff so that we can tell Desmos what we want it to do. So let's go back to our notebook paper, and let's do our next problem. So you might want to bookmark Desmos like sometime soon-ish now. Yeah, you'll just click the blue button that says graphing calculator. You see it there? Did y'all get to Desmos? Oh my goodness. Okay, you might want to switch seats because there are dead spots in these rooms still. I can't explain it, but no matter where you are. Okay. So here's our next math problem, and this is the part that we need to do on paper. I understand you're probably eager to start typing stuff in. It's a human thing, adults, kids, it doesn't matter, but this part I need you to do with me on paper, okay? So this is our equation. So let's prep it so we can feed it in correctly to Desmos as a function equal to 0. Are we choosing left side or right side? That is correct. We want to definitely pull all of our stuff this time to the right because I am, again, going to be a slave to that x squared term. I don't care about left or right. I care about making him positive. So I'm going to pull my minus 4m squared across. How many m squareds will that give me? That will give me 6. And then I have to pull my plus 5m across as a minus. How many m's will that give me? Say it again. Negative 7m. And then, of course, to complete the project, I've got to take this minus 4, pull him across. How many constants will that give me? Plus 2. Today's lesson just doesn't work if you can't do basic things. If you forget to change the signs of things as you move them across at equals, you and I have much bigger fish to fry than today's lesson. Like we can't, that's not something we can drag around with us. That's got to just be done. So now that we've got it prepped and we got it equal to 0, it's time now to go into Desmos, and you all can do this along with me. We're going to do 6x squared minus 7x plus 2. And you don't have to hit enter or anything. It just automatically updates itself as you type. And so I'm not completely opposed to this graphing window. I do see that my answers are, so like when you go to the default, you see how hard it is? You're like, what is going on there? So it's really important that you learn how to zoom in. And if you don't, I have a scroll wheel on my mouse that makes my life a lot easier. It's harder with you guys in your touchpads. So there are these zoom buttons over here on the right. So you can actually just click those, and that accomplishes the same thing as what I'm doing. So which one would we say when you look at this now is a freebie? Yeah. So it's not a whole number this time, but that's okay. We're big kids here. We know and can see that one of the crossing points is at 0.5. And we know the decimal to fraction conversion for 0.5. What is it? It's a half. 0.5 is a half, god dang. So one of our answers is a half. So if I go back to my other piece of paper, this is another one where I'm going to want to reverse engineer the one that I'm not sure what it is. Because can you guys click on it and tell me what it is? Yeah. Do you know what that is? Yeah, it is actually 2/3. I mean, it's what it is 0.6 repeating. Desmos only shows 4 decimal places. So it's trying to show you 0.6666666, which of course is double 0.333333. And if point buttload of 3s is 1/3, then obviously point buttload of 6s is double that, 2/3. So if you know that, now you can just take that with you and this problem's over. If you didn't, then you would go and reverse engineer it like we talked about. So going back to my other page, let's say I didn't know that. If I know one of my answers is 1/2, then I can actually build a factor of 1/2. You see that factor that I just wrote would definitely produce what we want, 1/2, right? And then let's just reverse engineer. So what has to go where this white arrow is pointing? Remember, it has to make 6m squared, so you need a 3m. And what does my sign have to be? A negative, so minus. And then what has to go in this blank to make 2? And there it is, just like Goblins told us, 2/3. You can literally see it with your own eyes. There it is. So all I'm going to write on today's worksheet is m equals 2/3 and m equals 1/2. Right? So Desmos is carrying a lot of the weight for us today. That's what I wanted today's purpose to be. Any questions? Okay. All right, I'm going to hand out the worksheet and I'll kind of get out of the way. I assume you're going to want to go over some problems, but I, of course, will never know that if you don't ask. So make sure you just ask.